Right now, something impossible is happening in our solar system. An object is racing past the sun at speeds we've never recorded before, and what makes it truly extraordinary is that it doesn't belong here. It came from the void between stars, from a place so ancient it existed before Earth was even born. We call it 3I Atlas, and for the past 4 months, scientists have been scrambling to understand it. Nearly 100 research papers have been published, telescopes around the world have tracked its every move, and what they've discovered is rewriting everything we thought we knew about interstellar visitors. Today is October 29th, and something critical is happening. 3I Atlas is making its closest approach to the Sun, swinging around at a distance of 210 million kilometers. That's about 1.4 astronomical units, which places it just inside Mars's orbit. This moment, called perihelion, is when the object is at its most active. The Sun's heat is blasting material off its surface, creating spectacular displays of gas and dust that should be lighting up the sky. But here's the frustrating part: we can't see any of it. The Sun's glare is completely blocking our view. We're on the wrong side of the solar system, watching one of the most significant cosmic events in recent history happen behind a curtain of light. But while we wait for it to reappear, we can piece together the story of how this ancient wanderer found its way to us. July 1st, 2025. The Asteroid Terrestrial Impact Last Alert System, a network of telescopes scattered across Hawaii, Chile, and South Africa, detected a new moving object in the night sky. At first, it seemed routine. Just another asteroid drifting through space. But then someone checked its velocity, and everything changed. The object was moving at 58 kilometers per second. To put that in perspective, Earth orbits the Sun at 30 kilometers per second. Mercury, the closest planet to the Sun and one of the fastest objects in our solar system, moves at 48 kilometers per second. This thing was outrunning everything. And it was still way out near Jupiter, over 4 astronomical units from the Sun. At that speed, there was only one explanation: it wasn't from here. This was the third interstellar object ever confirmed to pass through our solar system. The first was Oumuamua, that bizarre cigar-shaped visitor that sparked countless theories and debates. The second was 2I Borisov, which was surprisingly normal, just a regular comet that happened to come from another star system. But 3I Atlas is different. It's bigger, much bigger. Oumuamua was about 400 meters across. Borisov was a kilometer wide. 3I Atlas could be as large as 5.6 kilometers. It's moving twice as fast as its predecessors. And most strangely, it came from a completely different direction. Oumuamua and Borisov both arrived from the north, from the general direction our solar system is heading as it orbits the Milky Way's center. We essentially ran into them head-on. But 3I Atlas hit us from the side, perfectly aligned with the plane where all our planets orbit. Imagine our solar system as a flat disk spinning around the Sun. 3I Atlas came in almost exactly level with that disk, tilted by only 3 degrees. Pluto's orbit is tilted by 17 degrees, and we consider that unusual. For something to approach us from the vast three-dimensional ocean of space and hit us this precisely aligned, it's an incredible coincidence. Or maybe it's not a coincidence at all. We traced its path backward through space, and what we found was haunting. 3I Atlas came from the direction of the galactic core, from the thick disk region of the Milky Way, a quieter, older part of the galaxy where stars are more spread out and things remain undisturbed for billions of years. Astronomers believe this object could be 7.6 billion years old, nearly twice the age of Earth. It's a relic from when the universe was fundamentally different. Scientists managed to backtrack its journey over 10 million years, identifying 93 stars it would have passed during that time. But here's what's staggering. The closest it ever came to any of those stars was 0.3 light-years, which is 63,000 astronomical units. Right now, it's just $1.40 from our sun. For millions of years, this object drifted through the emptiness, never getting close to anything. And then it found us. We actually spotted 3I Atlas before its official discovery. On May 7th, it appeared in images from TESS, a satellite designed to hunt for exoplanets. For about a month, TESS happened to be pointing in the right direction, giving us an unexpected chance to watch the object as it traveled through Jupiter's orbit. Scientists immediately began measuring its brightness, and that's when things got weird. As 3I Atlas moved closer to the Sun, traveling about 1 AU during that month, astronomers expected its brightness to increase by a factor of 1.5. Standard physics. But what they observed was a 5-fold increase in brightness. The object was reflecting far more light than it should. That told them it wasn't an asteroid. It was a comet beginning to form its coma, that fuzzy halo of gas and dust that makes comets so distinctive. Except there were two massive problems with this observation. First, when they analyzed how light scattered off the coma, they discovered 3I Atlas has the most extreme negative polarization ever recorded. Most objects in space reflect light in a predictable way, bouncing it off to the sides. 3I Atlas bounces light straight back. No one knows why. It suggests the materials making up this object are fundamentally different from anything we've encountered before. Second, it was forming a coma way too early. This was happening beyond Jupiter's orbit, over $5 from the Sun. It's incredibly cold out there. Comets from our solar system don't usually develop comas until they're between $3 and $4 away, when the Sun's heat becomes strong enough to sublimate the ice on their surface. But 3I Atlas was already active, already shedding material into space, and when scientists pointed more powerful telescopes at it, they understood why. The coma wasn't made of water vapor like normal comets. It was dominated by carbon dioxide gas, with a ratio of about 8:1 compared to water. That's the complete inverse of what we're used to seeing. Carbon dioxide ice, the stuff we call dry ice, sublimates at much lower temperatures than water ice. That's why the coma formed so early. 3I Atlas was essentially a giant ball of dry ice hurtling through space, venting gas even in the outer solar system's deep freeze. But as it got closer to the Sun, something changed. By late September, as it passed through Mars's orbit at just over $1.50, the object suddenly started releasing massive amounts of water vapor. Scientists described it as equivalent to a fire hose running at full blast. More water than they'd ever seen from a comet at that distance. The composition was shifting, becoming more familiar, more normal. But it was happening in the strangest way possible. Then there was the metal. When they analyzed the coma during the summer, astronomers detected nickel but no iron. That shouldn't be possible. Nickel and iron are forged together in the cores of dying stars, then scattered into space when those stars explode. They're almost always found together in comets, asteroids, planets, everywhere. So where was the iron? What process could have separated them? And why was any metal sublimating at all when the object was still so far from the Sun, in a region far too cold for metal to melt? The answer seems to be that the violent outgassing of carbon dioxide was dragging nickel atoms along with it. But that still didn't explain the missing iron. Until September, when iron suddenly appeared in the coma for the first time. Within days, the ratio of nickel to iron normalized, becoming typical of what we'd expect. 3I Atlas was transforming before our eyes, shedding its alien characteristics and starting to behave more like a regular comet. But why? Was it always this way, or did something change during its approach to the Sun? Even its tail was wrong. When scientists first observed a tail forming in the summer, it was pointing toward the Sun. That's backwards. Solar wind blows away from the Sun, and it's supposed to push the tail in the same direction. But 3I Atlas's tail was facing the wrong way, possibly because the coma formed so early, and so far out that the solar wind wasn't strong enough yet to shape it properly. The gas and dust just accumulated on the sun-facing side of the object. Eventually, by September, a normal fan-shaped tail developed, pointing away from the sun like it should. But for a while, 3I Atlas defied even the basic physics of how comets are supposed to look. On October 3rd, we got our best view yet. The object passed within 19 cents of Mars, closer than it would come to any other planet. And we had cameras ready. The Perseverance rover photographed it from the Martian surface. It wasn't much, just a streak of light across the sky because the rover's camera wasn't designed for this kind of observation. They had to take 30-second exposures and stack multiple images together. The European Space Agency's ExoMars orbiter got a slightly better shot, showing the coma more clearly, but still not enough detail to distinguish the object's actual surface. NASA's Mars Reconnaissance Orbiter has the most powerful telescope in the Mars system, capable of capturing that fine detail. But if they took a picture, it hasn't been released. The U.S. government shutdown has left NASA staff sidelined, and we're stuck waiting. Now the sun is blocking our view again. We won't be able to observe 3I Atlas until early December, and by then it will be $1.10 away, moving fast toward the edge of the solar system. On March 16, 2026, it will make one final close pass, this time by Jupiter, flying within 36 cents. The Juno probe will have one last chance to photograph it before it disappears into the darkness forever. By then, it will be cooling down, becoming less active. But it might look different. The sun may have changed it, stripped away layers, revealed something beneath. And that will give us our final piece of the puzzle. Because here's the truth we're starting to understand. Maybe the strangeness of 3I Atlas didn't come from wherever it was born. Maybe it's just the accumulated weirdness of a 10-million-year journey through the void. Maybe every interstellar visitor carries with it the fingerprints of everywhere it's been, every star it passed, every cloud of gas it drifted through. We may never know where 3I Atlas truly came from. But it's showing us something profound, that the universe is far stranger and more diverse than we ever imagined. That what's normal in one star system is alien in another. And that out there, in the incomprehensible vastness between the stars, objects older than worlds are silently drifting, waiting for their moment to pass through someone's sky and change everything they thought they knew. 3I Atlas is leaving now. Soon it will be gone, and we'll be left with our measurements, our theories, and our questions. But something tells me this won't be the last visitor. And maybe the next one will be even stranger.